To illustrate the basic concept behind solving exponential equations, consider a number like 8. There is only one number that equals 8, and that number is 8. Since 8 is a power of 2, we can write 8 as 2 cubed. Thus, 2 cubed equals 2 cubed. If we replace one of the exponents with a variable, x, then we now have 2 to the x equals 2 cubed. Clearly, for this equation to be true, x has to be 3. No other value of x would make this equation true. This is the basic concept of exponential equations. In other words, to solve an exponential equation, we aim to have single powers on either side of the equation, where either the bases are equal, in which case we equate the exponents, or the exponents are equal, in which case we equate the bases. So, to solve exponential equations, we aim to have single powers on either side of the equation, where either the bases are equal, or the exponents are equal. Solve for x if 2 to the x minus 1 equals 8. First, note that the variable we want to solve for, x, is an exponent. To solve for x, we therefore need to have single powers on either side of the equation that have the same base. As it is right now, the bases are not the same, as 2 does not equal 8. We will therefore express 8 as 2 cubed. Thus, 2 to the x minus 1 equals 2 cubed. And now that we have single powers with equal bases on either side of the equation, we can equate the exponents. Therefore, x minus 1 equals 3, which means that x equals 4. Solve for x if 2 times 3 to the x equals 486. To solve for x, we need to isolate the term that contains the variable, which is 3 to the x. This term is multiplied by 2, so to isolate the variable term, we will first divide both sides by 2. Thus, 3 to the x equals 243. The next step is to express 243 as a power of 3, since we have the base 3 on the left. 243 equals 3 to the 5, therefore 3 to the x equals 3 to the 5. And now that the bases of the powers on either side of the equation are equal, we can equate the exponents. X therefore equals 5. Solve for x if 4 to the minus x equals 256. A general rule of thumb is to express each base in terms of a prime base, but since 256 is a power of 4, we will write 256 as 4 to the 4. Thus, 4 to the minus x equals 4 to the 4. And since the bases are now equal, we can equate the exponents. Thus, minus x equals 4, which means that x equals minus 4. We could have also expressed 4 as 2 squared, and 256 as 2 to the 8. We now have 2 squared, to the minus x, equals 2 to the 8. Since we are raising a power to another power, we multiply exponents, thus, 2 to the minus 2x equals 2 to the 8. The bases of the powers on either side of the equation are equal, which means that the exponents are equal. Minus 2x equals 8, which means that x equals minus 4. If you are unsure about anything we have just done, or just want to refresh your memory, these are covered in detail in the workbook, and in the online courses, the links of which have been provided in the description box below. Solve for x if 3 to the x plus 2 equals 1 over 81. Firstly, all bases should be prime, so we will express 81 as 3 to the 4. 1 over 3 to the 4 equals 3 to the minus 4, which is the fourth law of exponents. So we now have 3 to the x plus 2 equals 3 to the minus 4. Since we now have single powers with equal bases on either side of the equation, we can equate the exponents. Thus, x plus 2 equals minus 4, which means that x equals minus 6. Solve for x if 5 to the x equals 0.04. This is slightly different, but not any more complex. Since we have a decimal number on the right, we will first express it as a fraction, as 4 over 100, which in simplest form, equals 1 over 25. 1 over 25 equals 1 over 5 squared, and using the fourth law of exponents, equals 5 to the minus 2. Thus, 5 to the x equals 5 to the minus 2. And now that we have single powers with equal bases on either side of the equation, we can equate the exponents. Therefore, x equals minus 2. Solve for x if 2 times x to the 5 equals 64. In this example, x is a base, which means that to solve for x, we will need to ensure that we have single powers with equal exponents on either side of the equation. So, to isolate the variable term, we will first divide both sides by 2, to give x to the 5 equals 32. 32 equals 2 to the 5, therefore, x to the 5 equals 2 to the 5. We now have single powers on either side of the equation that have equal exponents, which means we can equate the bases. Thus, x equals 2. Solve for x if a third x cubed equals 9. We need to isolate the variable term, so we multiply both sides by 3 first. Thus, x cubed equals 27. We now express 27 as 3 cubed, since the exponent on the left is 3. Therefore, x cubed equals 3 cubed, which means that x equals 3. When solving exponential equations that involve rational exponents, we first isolate the term that contains the variable, and then we raise the exponential term to its reciprocal power. Before we continue, recall that a rational number is any number that can be expressed as a fraction. Rational exponents are therefore fractional exponents. Also recall that the reciprocal of a number is obtained by inverting the numerator and denominator of that number. Solve for x if x to the 3/4 equals 8. To solve these types of exponential equations, we need to ensure that the exponent of the variable term is 1. The exponent of x is 3/4, so to make this term x to the 1, we need to raise this term to its reciprocal power. In other words, we raise x to the 3/4 to the power of 4 over 3. But what we do to one side we must also do to the other side, so we also raise 8 to the 4 over 3. Recall the law of exponents that says we multiply exponents whenever raising a power to another power. So on the left we now have x to the 1, which is just x. And on the right we have 2 cubed to the 4 over 3, which equals 2 to the 4. X therefore equals 16. Solve for x if 2 times x to the minus 2/3 equals 32. The first thing we do is to isolate the term that contains the variable, so we divide both sides by 2. Thus, x to the minus 2/3 equals 16. Now, we raise x to the minus 2/3 to its reciprocal power, so that the exponent becomes 1. So we raise both sides to the power of minus 3 over 2. We now write 16 as 2 to the 4. X therefore equals 2 to the minus 6, or 1 over 64. If you liked this video, subscribe below, hit the like button, and leave a comment to let us know what else you'd like to see. Thanks for watching.